Hi, this is Bill Reese, and we're going to spend some time talking about the concept of risk, specifically risk and risk aversion. We're going to go about kind of proving or giving some evidence to the fact that individuals are risk averse. It'll be helpful for you if you follow along in the class notes that we've got for you that are titled Risk and Risk Aversion, Part 1. What we're going to do is we're going to set up the foundations of what's called modern portfolio theory. Modern portfolio theory is how investors have been managing money for probably the last 30, 40 years or so. And it's based upon certain premises, certain foundations. And not everybody, by the way, agrees with those foundations. Okay, so that's something we'll talk about later on. But they are based upon certain foundations. And one of those principal foundations that is that investors are risk averse. So we kind of need to define what is risk if investors are risk averse. One of the best definitions of risk that I have heard is this. Risk is any time more things can happen than will happen. Anytime more things can happen than will happen. So if there's only one thing that can happen, and that does happen, there's no risk. But if there are two or three or four things that could happen and only one of them will happen, then there is risk. A lot of people think about risk in terms of possibility of something going down. And that's certainly what we're generally more concerned about. But that's not our definition of risk. Our definition of risk is going to be anytime more things can happen than will happen. So let's take a look at an example of something that has no risk and something that has risk. So I'm going to go into the share mode here and bring up from the notes, okay, because I think that's the easiest way to do this. First of all, an investment that has no risk. So let's suppose you have $100,000 today, right? And you have an opportunity to invest it. And one of those possible ways to invest it is into an investment that will give you $5,000 or $105,000 at the end of the year. So this is your first opportunity. We'll call this a risk-free investment. You invest $100,000 today, okay, here, and at the end of the year, you will for sure have $105,000. Second opportunity, second choice of how to invest the money is you have $100,000 today, and you don't know what's going to happen at the end of the year. There is a 0.6 probability that you will have $150,000 at the end of the year, and a 0.4 probability that you'll have $80,000 at the end of the year. Now, I've said this at the end of the year just as a convenience sake. I could have just as easily said at the end of the week or at the end of the month or at the end of the decade. The time period really doesn't matter in this particular case, but we tend to think in terms of years, so we'll make it easy in terms of years. So what we want to do to begin with is we want to calculate, obviously this is what we call a risk-free investment here because there's only one thing that can happen and that in fact will happen. We call this a risky investment because there are two things that can happen, okay? But only one of them will happen. And of course, whenever we have probabilities, we know probabilities have to add up to one as they do in this case. So what we want to do is we want to calculate what we call the simple returns on each of these. Okay, a simple return means it doesn't matter how long it took for this to happen. It's just that it's going to be how much we made divided by how much we invested. So if we scroll down here to the next page, let's take a look at our risk-free investment, and we will denote risk-free with this R sub F right there. Whenever you see R sub F, it means a risk-free investment. Only one thing can happen, and it will happen. And as we've talked about before, it has a standard deviation of 0. That's our definition of a risk-free investment. So one way we can take a look at this is how much we made is 105,000, which we end up with, minus 100,000 that we started out with, divided by how much was invested, $100,000. But you notice we've got 100,000 in the numerator and 100,000 in the denominator. They can cancel out. So we can say 105,000, which is what we ended up with. 100,000 is what we start with minus the 1. That's the 100,000 over 100,000. Either way is perfectly acceptable. And that equals 5%. So we would say that is the simple return, because whether it's a week, a month, a year, or a decade, you have earned a 5% rate of return, okay? How much we made divided by how much was invested. So that's a risk-free rate. That's the risk-free rate of return there. Now, on the risky investment, we are going to denote this as an expected return, because we don't know what the return is going to be. Okay, we could end up having a return that gives us a 50% rate of return. We could have a return that ends up losing 20%. So we want to statistically calculate what is the expected return. So the way we're going to do that, we say the expected return, and when you see this E, then with an R in parentheses, that will always mean expected return. So it's our probability of the 150,000 divided by 100,000 minus 1. That's our 50% rate of return. So we put a 0.6 probability on that and a 0.4 probability on the 80,000, which we would end up with, divided by the 100,000, which we would start out with, minus 1. And so that's going to equal 22%. So we have an expected return of 22% on the second investment, on the risky investment. Now, it's important to understand that this does not literally mean we expect to get 22%. In fact, we know we're not going to get 22%. We will either get a 50% rate of return or a negative 20% return. But statistically, the way we express that is an expected return of 22%. So which investment should somebody choose? Should they choose investment A, which gives you a 5% rate of return guaranteed, or should you choose investment B, which gives you an expected return of 22%? Well, we want to see how in modern portfolio theory we figure that investors will make that decision, and that's not a simple thing. There's been tons and tons of research and papers and disagreement and thought gone into what causes some investors to choose the 5% rate of return for sure, versus others which will choose the possibility or the expected rate of return of 22%, investment B. And what I'd like you to do right now, I'd like you to say, hey, if I have $100,000, and think of this, I mean, that's a lot of money for most of us. So think about this as being a significant investment. If you have $100,000 and you have just these two choices, okay, just for 1 year, let's say, okay, how will you invest that money? Will you invest it into investment A, which gives you $105,000 at the end of the year, or will you choose investment B, which has the 0.6 probability of getting $150,000 and a 0.4 probability of ending up with $80,000 at the end of the year? And if you give this some serious thought and write it down somewhere, we will come back to this later on in this unit, and you will learn something about yourself through what your choice was on this. Well, the first thing we want to do is we want to calculate what's called a risk premium. A risk premium is an extra return that investors get above the risk-free rate as compensation for taking on risk. As we're going to see, modern portfolio theory comes under, has the assumption that investors are risk averse. And if they are risk averse, they don't like risk, but they are willing to take on risk sometimes if they are offered a risk premium. So a risk premium is the extra return above the risk-free rate that you can get with a risky investment. So in this case, if we can get 22% rate of return, expected rate of return on the risky investment, and 5% is the return we get risk-free, the difference between those two is going to be the risk premium on the risky investment, which is going to be 17%, just the 22% minus the 5%. There's a couple different ways that can be calculated, but it's pretty intuitive. So the next thing we want to do is we want to determine how risky is the risky investment. And we talked about before, the way we measure risk is volatility, and we can measure volatility either through variance or through standard deviation. And we learned how to do both of these earlier. So first thing we're going to take a look at is variance here, okay? The variance of that risky investment is going to be 0.6. It's the probability of getting the 50% rate of return subtract from that the 22%. So we want to say this first data point of 50%, how far is that from 22%, which is the expected return? Square that difference, and again, multiply it by the 0.6 probability. Then we say the second data point was negative 20%. How far is that from our expected return of 22%? And then we square that distance, multiply by the probability of getting that negative 20%. And then you do the math on it, and we come out with a variance of 0.1176. Once you've got the variance, very easy to get the standard deviation. You take the square root, and typically variance is expressed as a decimal. Standard deviation is expressed as a percentage. So here we have the square root of the variance gives us the standard deviation of 34.29%. So that's a measurement of how much risk is in the risky investment. Of course, the risk-free investment by definition has a standard deviation of 0. So again, we've got two choices. You can get a 5% rate of return with a standard deviation of 0, or you can get an expected return. And we wouldn't say you can get a return of 22% because we don't know what the return is going to be, but you can get an expected return of 22% with a standard deviation of 34.29%. Again, there's not a right or wrong answer to this. Some investors will choose the risk-free investment. Some investors will choose the risky investment. And we're going to try to figure out why some investors choose one, some investors choose the other. What is it about investors that causes them to make the choice that, the particular choice that they make? Okay. Well, in order to come up with this conclusion that investors are risk averse, okay, it can actually be proven, and I'm not going to go into the details on this, okay. We could if we had time, but I would prefer not to. If you have questions on it, we can certainly do that when we have our live sessions. But you need two assumptions for this to say that investors are risk averse, and these are both very reasonable assumptions. The first assumption is that investors always prefer more to less, that you would rather have $100,000 than $50,000. You would rather have $200,000 than $100,000. Most of us would agree that that is a reasonable assumption, that people prefer more wealth to less wealth. The other assumption that we need to have in there is that the marginal utility of wealth is decreasing, meaning you get more utility. That's an economic concept. That's like happiness, enjoyment, okay, good feelings. You get more utility out of that first $10,000 of wealth. In other words, if you go from no wealth to $10,000, the amount of utility you get from that is greater than the amount of utility you would get going from, let's say, $100,000 to $110,000. So in other words, if you had no money, you were totally dead broke, and all of a sudden somebody gave you $10,000, think how that would make you feel, okay? Then think, all right, if I have $100,000 and somebody gives me $10,000, so I go from $100,000 to $110,000, how does that make you feel? Well, both of them make you feel good, but I bet you would say I get more utility going from 0 to 10,000 than I do from 100,000 to 110,000. Or take it to a further extreme. Suppose you have $1 million and you go from $1 million to $1,010,000. You like getting that extra $10,000, but it's not such a big deal as it would be going from 0 to $10,000. So as a result, if we are willing to say that investors are going to always want more, okay, but that as they get more, their additional utility of getting more on top of that is decreasing. Our marginal utility of wealth is decreasing. Then we end up with the conclusion that investors are risk averse, because what it means is that losing money hurts more than gaining the same amount of money. In other words, if I'm going to lose $50,000, that hurts worse than if I gain than the good feeling I get from gaining $50,000. So if I'm at $100,000, okay, and I lose $50,000, that puts me closer to that 0 point, okay, where every dollar means a lot to me. But if I'm at $100,000 and I make $50,000, okay, that puts me closer to that millionaire status where the extra money is nice, but it doesn't mean nearly as much to me as when I'm very poor, okay? So if we say that it hurts more to lose $50,000 than it feels good to win $50,000, that makes us risk averse. Because if I'm engaged in, let's say, what we call a fair gamble, okay, where I have a 50% chance of losing $50,000, 50% chance of gaining $50,000, I typically won't do that, because the utility I get of gaining that $50,000 is less than the utility I would lose from losing the $50,000. Let's take a look at a real simple example and ask yourself how this would work for you. Again, suppose we have a game here where it's a coin flipping game, and it's a fair coin. Okay, so 50% chance of getting heads, 50% chance of getting tails. If I flip the coin and would get heads, you're going to get $150,000. Okay, we're going to play this game one time and one time only. We're going to flip the coin and you get tails and you get $50,000. Well, so far you probably like this game pretty much. Okay, I'm going to flip the coin. If it's heads, I give you $150,000. If it's tails, I give you $50,000. You probably say, hey, let's play the game. But there's a catch to it. And the catch is that there is an entry fee to play the game. The question is, how much are you willing to pay to play the game? Are you willing to pay $50,000? Well, of course you're willing to pay $50,000 to play this game, because if we flip the coin and it's tails, okay, you get back your $50,000. Okay, if we flip it in its heads, then you get $150,000. Would you be willing to pay $150,000 to play the game? Of course, you would not be willing to pay $150,000, because the best thing that could happen to you is we flip the coin in its heads and you get back the $150,000, and you're no better off than you started with. But if we flip tails and you paid $150,000 to play the game, you only get back $50,000. So all of you, I'm sure, would be willing to pay $50,000 to play this game, but none of you would be willing to pay $150,000 to play the game. What's the most you would be willing to pay? What's the point somewhere between $50,000 and $150,000 where you would be exactly indifferent between playing the game and not playing the game? Modern portfolio theory says that we are risk averse, which means, since this is a one-time only game, that we're not willing to pay $100,000 to play the game. And I assure you, I would not be willing to pay $100,000 to play the game. $100,000 means enough to me. I couldn't set down $100,000, have somebody flip a coin, and have a 50% chance that I lose $50,000 of that $100,000, even if I have a 50% chance of gaining that money. Because if I came home at the end of the day and I told my wife, I said, guess what, honey? I had a chance to make $50,000 today. She says, great. Okay, I say, unfortunately, the coin flip came up tails instead of heads, so I lost $50,000. You know, I'd be sleeping out in the garage for the next couple of weeks, okay, if I bet $50,000 on a coin flip. So most of us, and modern portfolio theory assumes all of us, the amount that we're willing to pay to play that game is at least $50,000, but it's not going to be as high as $100,000. So that's our definition of people who are risk averse, that you need to be having the odds in your favor, or you need to be having the payoff in your favor in order to play the game. There needs to be a risk premium attached to that. Now, we can kind of see this in terms of the concept of insurance, by the way. Let's suppose that you have a house, okay? And suppose with your house, there are two things that could happen to this house, okay? A is nothing happens to your house, okay? B, there's a fire and it burns to the ground. Now, we're gonna just kind of arbitrarily say your house is worth $100,000 and the chance of having a fire is 1 in 1,000, okay? So if you have the fire, then you lose $100,000 and your house is worth nothing. If you don't have a fire and the chances are 999 out of $1,000, then you have no loss and the value of your house is still $100,000. So we would say the expected loss from the fire is the probability of the fire, which is 1 in 1,000, multiplied by how much you lose if there is a fire, $100,000, plus, and we don't have to do this step, but we'll do it anyway, the probability of no fire, 999 out of 1,000, times the loss if you don't have a fire, which is 0. That's why we didn't have to do it. And that ends up with the expected loss from the fire statistically is $100. So when we're faced with this situation, okay, we have an expected loss from a fire of $100. Now, the question is, in this scenario, are you willing to pay for homeowners insurance, okay, where your premium would be more than $100? Let's just say $110 a year. Would you be willing to pay $110 a year to insure you against the loss of a fire? And the answer for almost everybody, or I hope for most of you guys, is that yes, you would be willing to pay $110. I know I certainly would be willing to pay $110, even though that's a negative NPV investment. It's negative NPV for you. It's a positive NPV investment for the insurance company. So I would feel better about knowing for certain I'm going to lose $110 than having a 1 in 1,000 chance of losing $100,000. Because see, if I lose $110 by paying the premium, it's not going to change my lifestyle. Okay, I'm still going to have Christmas. I'm still going to be able to put food on the table. I'll still be able to give my grandchildren, presents on their birthdays and stuff like that. Okay, I don't want to pay the $110, but it's not going to fundamentally change things for me. However, if we have the fire and the house burns down and I lose $100,000, that is going to change my life. We're not going to have Christmas this year. Okay, there may not be food on the table, and I probably don't have money to give the grandkids any presents. So I'm not willing to risk that. I would feel better about a guaranteed loss of $110 than this expected value loss of $100 because it's got so much volatility to it. I could end up losing $100,000. Well, if that's how I feel, and that's how most of you feel, we're going to go to the assumption that everybody feels that way, and everybody is risk averse. Now, while this is technically not correct, that everybody is risk averse, it's certainly true that the vast majority of money is managed in a risk averse manner. Okay, so we're not saying that the vast majority of people are risk averse, although I think they are, but we're saying the vast majority of money is managed in a manner that is risk averse, because most money is managed by professional money managers, by pension funds, by mutual funds, insurance companies, things such as that, hedge funds. Most of it is not managed by mom and pop who do their own investing. Most money is managed by professional money managers, and they do manage it in a manner that is consistent with this concept of risk aversion. So we're going to go through this whole section, okay, on portfolio theory based upon the concept that individuals are risk averse. Our definition of risk averse is that individuals want a higher expected return and they want a lower standard deviation. Both of those things, a higher expected return and a lower standard deviation. Now, another way of putting that is that individuals are only willing to accept a higher standard deviation if they are offered a risk premium. Okay, the risk premium is a higher expected return. Individuals are only willing to accept a higher standard deviation, which is something they don't like, if they are offered a risk premium. One example of this might be, let's suppose there is a dessert that you really, really like. For me, it's Boston cream pie. I love my wife's Boston cream pie. But let's suppose in order to be able to eat that dessert, okay, you have to meet a requirement. And the requirement is you have to eat some vegetables that you don't like. For me, that's Brussels sprouts. I really don't like Brussels sprouts. So let's suppose my wife says, hey, Bill, okay, I've got some Boston cream pie for you tonight for dessert. I say, oh, that's great. She said, but in order to eat that Boston cream pie, because I think it's good for you, you need to eat your Brussels sprouts first. Well, as much as I dislike Brussels sprouts, I'm willing to eat some Brussels sprouts in order to get the Boston cream pie for dessert. Now, I'm not willing to eat a big bowl of Brussels sprouts for just a little sliver of Boston cream pie. Okay, but I am willing to eat, let's say, one Brussels sprout for a big piece of Boston cream pie. Okay, so what's the trade-off between Brussels sprouts and Boston cream pie? Well, it's going to be different for different people, okay, depending upon how much you like the Boston cream pie, how much you dislike the Brussels sprouts. And the same thing is true with risk aversion. For all investors, we're going to say, just like Boston cream pie, you want a higher expected return. But just like Brussels sprouts, you don't want standard deviation. But just as I am willing to eat some Brussels sprouts when I'm offered Boston cream pie as compensation, risk-averse investors are willing to take on standard deviation if they are offered a higher expected return as compensation. How much extra expected return must an investor be offered in order to take on some standard deviation? That is different for every investor. So not every investor has the same degree of risk aversion. We're all risk averse, meaning we all dislike standard deviation and we all like expected returns, but some investors are more risk averse than others. So in our next video, we're going to be talking about how to measure that degree of risk aversion that each of us has.